Welcome, and this is another video on deep diving into some coding tricks and tips. This video will be just a general tips and tricks on kind of a coding principle, and we'll be talking about structs right now. So I actually do a couple of videos on just tips and tricks I have for structs, and we'll just start out by talking about how I generally go about making a struct and why I might use a struct in the first place. So for people that might not be aware, a struct is a very simple data type, and it can be very easy to end up confusing it to a class. So if you come up here to Visual Studio, you can see that you can instantiate either a class or a struct. And what's very difficult sometimes is they can look like they do the exact same thing. So you can declare functions inside of structs, and you can declare a struct just like you would declare a class. You can give it a constructor. You can give it all kinds of methods and attributes. And so it looks just like a class, but there are some kind of nitpicky differences that just in the basic C# implementation. So for instance, a lot of times structs actually can by default, a lot of their attributes are not going to be exposed. And I mean, this is actually kind of similar to a class, but it can be a lot harder to get to some of the attributes in a struct. So you'll kind of often find yourself doing like maybe this public string name and doing these doing these kind of accessor methods on your struct, whereas in a class you wouldn't necessarily have to do these get sets with it. And there's other just kind of basic things, and I'm not going to go over kind of the basics of what a struct and a class is. Go seek out some documentation. There's great tutorial videos on C#, but and structs are kind of going to be different in all kinds of languages, so I don't want my tutorials to be too specific to C#, but just know that in general, we're just going to focus on the way that a struct might be used versus a class. So if you followed along with any of my other tutorials, you've seen that we've mostly worked with classes so far, and we've used a class to kind of do some modification to some set of data. And this is actually a design principle. Just using classes to modify data, to componentize some set of actions on data and then pass it on. So that's a lot of what a class tends to be, whereas a struct tends to be the module that we pass along from component to component. So you can think a class is a component, whereas a struct is that module of data that we pass from one class to another class. So in a very basic sense, you can think of a string as some module of data that you pass between classes. But then when you want to get a little more complex and you want to have things that have a lot of attributes to them, then you can either pass a class or a struct in between methods. Now, it is very common to pass classes along the path between two different components. So let's just kind of take, for example, if I just come here, I'll just make a new class, and I'll end up kind of destroying these a little bit later. But if I have this basic class here, what I can do is I can make another class down here that's maybe called call me, and it just has some default constructor called, and let's just say that, well, actually I won't give it a default constructor, but I'll actually make it take in an instantiation of basic class. So it comes in like this, and then maybe basic class has some method down here that's like public void do something, and what the constructor of call me does is it calls the basic do something method. So here is an example of some sort of data transfer going on. So it's a very basic sense. We have hooked up the call me class to the basic class here. And they can choose with this do something can pass any kind of data to it. So I could actually change this to be a string data type, and that do something. So now we're passing strings to the call me method. So string.empty. And I'm being pretty messy here, but just kind of doing a very basic demo. So if you were diagramming this out, you might kind of see that in the lineup, you have this call me method here, which is making a little outbound arrow to the basic class over here. And then basic class internally has a do something method that does something and then eventually returns a string out. Now, the question kind of becomes, what do I do when I have a very complex thing to return out of the do something method? So this is a line of code that you would see everywhere. I would highly advise never calling functions inside the constructor, but that's another topic. But you would see this code just anywhere. This is just a very basic class calling another class. But like I say, the question comes up of, what do you do when you have a very complex data type that you actually need to pass back? So it's not so simple. It's no longer I'm just passing a string to this data, to this back from this method. Well, now I kind of have this thing that if we come over to our scratch pad, maybe this object needs to have all of these values. So I have a hard choice to make. I can make a class that holds all these values inside of it, or I can make a struct that holds all these values inside of it. You would never, it really doesn't come down to many other different types. There are enums and stuff, but enums would really be a part of a struct or a class. You wouldn't really want to encode something into a string object. There are other types of ways that you could think, but really it's the question when you're coding the library is going to come down to whether or not I'm using a class or a struct. So in our case, we have a very strong understanding of the data that we are sending on its way. So in this do something method, we actually can control, we're directly controlling what that object becomes. String.empty does not have to be sent out as a string. It could be, we could wrap that string in our own little struct or our own little class and send it on its way. So let me just show you kind of what that might look like, and kind of keep in mind that I'll actually go ahead and fix stuff right now. So we're gonna just separate out all our code just to make sure that we keep everything looking nicely. And pretty instantly. Okay, cool. So just to kind of like show that there's a very clean divide between these two. And so what I'm saying now is that I will actually have a more complex data type. So what I might do is, let's just wrap this string in a data type that's either a class or it's a struct, because a class and a struct are pretty much the exact same thing. So, and let's just say that this is actually someone's name. So I'll add, so we're going to make a new class and we'll call it name as class, though in your case you would just call this name, but I just want to be very clear, and then name as struct. Oops. Rename. Okay, cool. So let's just kind of look at what the differences would be on implementation and why it's actually a little bit tricky. It can be very hard to figure this stuff out and make a decision between the two. So both of them kind of by default get these constructors that you can define. They look pretty similar, and I'll actually put them up side by side. Let me don't know why. Pop to the right. I don't know why it's not showing. Did I get rid of the feature? Okay, for some reason I'm not able to pin it to the side anymore, but okay, that's fine. Okay, cool. Anyway, so you can see that both of these are actually pretty similar, and let's just say that we will define a variable that is name within them. So since this is a variable that we know that this class needs to carry, we're going to define it as a field variable. And so a field variable just lives inside the class. It's within the scope of every function that's defined inside this class is going to have access to this variable. So in this case, we know that it is name. So we know it's a string, and we know that it's a name. And we'll come here, and we'll say the same thing. It's a string. That's a name. And so now we have a question of kind of how are we going to get this name defined. So if we come here and we come to the basic do something method, it just wants to so eventually we want to swap this out with whatever the name of our class is, whatever the type of object is from this class. And so we can just come up here, and I'm just gonna say, let's assume right now that we don't define a constructor. So we don't interface with a constructor at all. We just use this to store data, and we define this using proper instantiators. So okay, so cool. So we see some things right now already. So by default, both of these. So you can notice by default oops, that's so tricky. I thought for sure I clicked struct. Okay. But so it's interesting to come down here and look at this. And so first thing you might notice is that private member name as struct.name is unused, and that's very interesting. You come over to class, same kind of thing, and we actually get one extra issue, right? Or non-nullable name must contain a non-null value when exiting constructor, considering declaring the field as nullable. So compilers complaining about some stuff. We just want to make sure that we are using this variable somehow. So the first thing I want to do though, before I even start messing with this, is just I want to go over to this method and start to just see what starts to change over here. So just to make my life a little bit easier, I'm gonna define two methods here. So name is class. They're gonna return two different, or both of our instantiations of name. So just so we can kind of see here that just what the difference in instantiation would look like. So obviously we can't return just a string anymore, so we will have to wrap whatever the value should be within our object. So if we say value, or we'll just say name, it's going to equal a new, and so now here's where we can start to pull in our structs. So if we say that, or we'll start to pull in our classes that we just made. So if we say new name as struct, and then we come here, we should, so this is interesting already. So when we're trying to instantiate this way, we're trying to access the field variable. So we notice the first problem is that we aren't accessing any field variables. So the first thing we should try to do here is expose it. Oops. So now If I come back here, I try to type it again, I do have access to a name, and I can just set it equal to string.empty. And so now I have this name class that is wrapping this string object, and I'll actually give it a name. So Joey. So we now have this name object, and it's being wrapped in this class, and we can now just go ahead and return it, and this should get rid of any errors. Cool. So we have this do something method that's returning this name, and so this, once again, this is very standard piece of code. So this has now become this more generic data container to transfer more information across the line. So before we had this data type that was just a string, and it was a very simple data type. But like I said, now we want to send things. We want to send a much more complex data type. So we're going to either choose a class or a struct to hold that data. And so right now you're just asking, well, what's the difference between implementing with a class versus struct? So we've just implemented with a class, so let's see what it looks like to implement it with a struct. So we should get some complaints as, and let's just see what doing public on this does. So we seem to be good. Name is not null here. Okay. So we seem to be good. So as far as the compiler, is concerned, we seem to be pretty good. It won't have many complaints, and so you might be saying, like, wait, like the code is exactly the same. Then what's the difference, right? These are gonna run almost the exact same, and there's the nuance in the question. So there will be no feature difference between using one versus the other, but there is just a custom for using one versus the other. So as I tried to explain before, you should think of a class as a modifier of data. It is a component. So you can think about, and try not to call it like a factory because that does something else, but you can think about it like almost like a toffee machine. You know, you send in this ball of sugar into the toffee machine, and a class will change and stretch it out and twist it and all this stuff, and then pass it out in some form. And that, whatever that form is, you should think about that form as a struct. And then that struct gets passed on to some other machine, which is another class, and that machine might stretch it out some more, or start to cut it up into different individual slices, and then it comes out, and whatever it comes out in, maybe that's a list of structs, or it's a bunch of other structs, but it's not another class, because those little modules, those little taffy modules, you would never want to call those a class because they're not doing anything, right? Or they're being acted upon, where a class always does the action. So that's just the kind of nuance that you're going to face when you're deciding which one to use. And when you're looking at old code bases, like especially old C++ code bases, you'll see a very clear delineation. People struct used to be kind of the only thing that you could use, but people tend to still today, when coding in a C++ background, they'll use struct to store all the data. So the state of a machine or the state of a program might all be stored inside of a struct that then gets loaded into a computer when it's booted up, or when a program boots up, and just attributes that you care about for your program. That all of that stuff's going to tend to be nicely laid out in a struct file just at the very beginning of your code. And so if you went through and read through this file, you would just see all these different struct files that would tell you and give you a good idea of the type of data that's passing through your program. And so you just want to be careful the kind of delineation that you try to have here. If we go up here to name as struct, you can see that this class, this is sometimes all a struct is just this declaration, and then it moves on. But a class rarely stays like this. A class tends to now have methods like void change name, and then it'll take a string and it'll say new name, and then it'll also have something like public void clear name, and it'll have something like translate name. So a class is expected to have all of these functions declared inside of it, whereas a struct would never have those methods declared because it mainly is serving as a data type. You might overload basic functions like a toString method, but it's not going to be something that's converting things to different languages. It would go inside of something that might convert it to a different language. So I would much rather see a class here that took in a name that was a struct and converted it to something. So I would prefer something like a name translator class that took in some struct up here like this. And then it did some operation on it to translate that name. See, so this would be a much nicer class. So what I'm going to do, I'm going to go ahead and just change this here to name. I'm going to rename this here so that you can kind of get a better idea of what this might look like in reality. So like I say, it's the differences are going to be very nuanced, but and you might actually see something store the name, but it wouldn't be something that would be accessed. It would probably be private. And really what someone might do is they might store the name variable that got passed into it here as a cache, but in our case we're a translator, so we would never store that variable. I'm going to go ahead and delete these methods that I defined here. And so here's the optimal way that you would see something laid out. So this name translator class now takes a dependency on the struct, and now whatever name that you want to translate has to conform to this struct that you get passed in. So now name is this data container that goes into the translate name call. It might go all throughout your program. If you're building a UI like a Twitter, then it might go to your profile generator. It might go to your feed generator or your personal profile view generator. So this model gets to travel all over your code, but this class doesn't really travel all over the code. It might get run by some batch service very early on in the day and never gets run again. And then it doesn't care about this model anymore. So, or really the program doesn't care about this class anymore. Whereas this model might go on to live for many, many days and be called many times. And so you wouldn't want to necessarily have to make a name translator every time you wanted to deal with a name, for instance, and it gets convoluted. But I hope that that's clear. What I want to go through before we leave is just making a very now that you know kind of why you would use a struct over a class. Like I say, a struct is a data container, whereas a class operates on that data. I just want to go through what the process then looks like for me when I just want to come in and make a struct. So I have the scratch pad over here, and it just has an example JSON. So say that I'm building an API and it's exposed out to the public, and I know that my JSON needs to look a little bit like this. Well, I don't really want to operate on JSON inside of my program. I'm okay with it being the language that I use to talk to all my APIs, but inside my C# code, I need to make a decision of a data type to use to store all this data. So for the reasons we just described, I'm going to go ahead and try to store this inside of a struct. So this is just a clean example of how I might define a struct. So here, let's just say that this is profile information. So I'm going to go here, and I'll just define a new struct called profile info. Okay, cool. So I now have this struct, and what I'll do now is I'm just going to go through each of these entries and define them here. So I'm just going to copy and paste this. And that was what I was looking for before. Okay. So, and this becomes pretty straightforward, I think, as you just kind of see it take place. So now I compose it of either simple data types, or otherwise known as primitives, or I can start nesting other data types inside of here. So you can think about, I could actually add other nests. So instead of using a string, I could actually use our name struct here instead. But in this case, I'm just going to use a string because I want it to be very simple. And notice that I keep using public right there because I want this thing to be accessible to the public. Public string pic URL. This is just the URL to maybe a profile picture. Is account enabled? Oops. So then maybe last active, that looks a lot like a date time. And so so this, you can see kind of clearly this actually is the very easy part of a project, yet so many people will skip over this step and they end up overcomplicating their program because they don't take this basic step. So here we've taken the time to cleanly lay out what the structure of our program is. I'm going to go ahead and delete this, but remember that it is available in the Scratchpad. So this is now the struct that contains all the data that I'm going to be using in my project. So whenever I need to access someone's profile info, I just need to make sure that I have something that's giving it to me in this format. So keep in mind that a struct is not necessarily how you store data in a database. So the way you store data in a database can be any number of ways. You can use SQL, you can use Postgres, you can use an XML, a text file, or whatever. But what's important is what data format you operate on or operate with. So if you build a database and it exports out to a text file, you need to make sure that the text file can spit out to a struct that's like this. And now once it can spit out to a struct just like this, now we can operate on the data. We can turn it into different data types and send it along the path. Maybe profile info is the first leg of the journey, and what we really want to do is get this person's email address and then join that with some other table that we have that's in another different data type, hopefully a struct, and we just want to join against it and get more data on this user, and then we want to format that into a new struct that we then pass on to another process to do some more manipulation on. So you can just see that struct to me is like the red blood cell of your program. A lot of people are not using it as much as it should be, but it is very clear, very clean to the user when they come up to read your code that, hey, this is only storing data. Do not add functions to me. I am just data that's getting passed on. And now someone can search for profile info throughout your code and understand what are all the places that people are using this data. So like I say, this is just a simple video going over, doing just a brief overview. It's actually a very complicated topic, but just a brief overview on just how you might go about making structs for your data. So in the future, I would like to talk about how, sharing structs between classes and sharing them between projects, and also just talk about buffing up your structs. So it is nice. While this is really, really nice and very clean, there are some things that we can do to kind of buff up our structs and make them a little bit more versatile for kind of more nuanced situations. So, but yeah, I hope that you will follow along. This has just been a tips and tricks video, all dealing with the basics of structs. So thank you, and I'll see you next time.